everyone, I'm going to show you how to solve Leetcode question 98, validate a binary tree, and it's a median Leetcode question. Giving the root of a binary tree, determine if it's a valid binary search tree. A valid binary search tree is like the left subtree of a node contains only node with keys less than the node key, and the right subtree of a node contains only nodes with keys greater than the node's key. Both left and right subtrees must also be binary search trees. So basically, a valid binary search tree is like the left side value is smaller than the root value, and the right side value is bigger than the root value. And then you also have to recursively validate the root.left with its child, and the right side validate with its child as well. So if you look at this example, 1 is smaller than 2, 3 is bigger than 2, so it's a valid binary search tree. For this one, if you look at the example here, sure, 1 is smaller than 5 and 4 is not bigger than 5, so it's not a valid binary search tree. Like the explanation they give to you, the node's value is 5, but its right child's value is 4, so it's a false. And if you look at it here, there's some constraint here, and this is a question asked by Amazon 26 times in the last 6 months. So it's definitely a great question to practice on. Essentially, what it's trying to do is that they want you to compare a value to make sure this, like every single node, you have to run this on every single node, check its left child and the right child, and to make sure the left side is smaller than the node itself and the right side child is bigger than the node, right? And then you want to run this recursively on node.left and the node.right. And if you think about it, is that this function that you're going to write, you can essentially pass the node as a parameter, and the other two parameter that you wanted to pass is actually the lower value and the higher value. The basically a range. The range for the left side is that the left range, it could be negative infinity, and the biggest value is what you're comparing is actually this value, the node vol, right? If it has to make sure it's in this range. On the right side of the node, the lower value you're comparing is the node vol, and the bigger value, it could be infinity. That's the range that you are comparing. Then you're gonna continue to call this function to run it recursively on the node.left and node.right to make sure that both of them are valid. And once you make sure both of them are valid, and then you can call the function. So I'm gonna show you how to do this in code, and I'm gonna write another function called is valid inside of this is valid BST function, so that I can pass more parameters, because right now there's only one parameter as root. So I'm gonna call this is valid here, and I'm gonna pass the first parameter as the node itself, and then a low value, a high value, basically specify a range for me to continue to run this recursively on node.left and then node.right. So first we want to rule out a case is that if it's an empty tree, if not root, right? I want to return true, because when a tree is empty, it's a valid binary search tree. So this is pretty straightforward. And then if I want to say if the node vol is bigger, then I'm gonna rule out the case that I'm gonna say it's false, is bigger or equal than the high value, or node vol is smaller than the low value. Basically, the whatever value I'm specifying here, if this node value is bigger than the highest value or smaller than which is not in range at all. In this case, it's not a valid binary search tree. I'm gonna have to return false in this case. And then I want to call the isValid function on the node.left, right? To run this recursively, node.left. After I'm calling this node, this is a function for the node, and I'm gonna call node.left. And I'm also gonna pass since I have two value here, low value and a high value. For the left node, I'm also gonna have to pass a low value and a high value. I don't know what the low value will be, right? It could be negative infinity, like really, really small number. But I know the high value. What a high value should be is actually the node.vol. Basically, is the 5. Does it make sense to you? Because if the node is on the left side, that I have to make sure that it's smaller than this node.vol. So I put the node.vol as the high value here. So I want to return this because if this is true, is valid function, calling is returning true, then this will return true, right? And if the function is false, then it will return false. And then after I checked the left side, I also wanted to run the same function and I check the same thing on the right node. And I'm going to call the isValid function and I'm going to say node.right. So what is the low high range for the right side, the right node? The low range that we already know is actually the node.vol. So for example, the node.right is 4, right? I want to make sure that the 4 is bigger than 5. So the low value that I'm passing into is node.vol. And then the high value, I don't know, it could be like infinity and something like that. But either way, this is the left node and this is the calling the function on the right node recursively. If I get both output return true, then this function will return true. That means it's a valid binary search tree. If either one is not true or both of them are not true, it's not a valid binary search tree. So that's it for the function itself. Then I'm going to call the function basically isValid, and I'm going to pass the function to run this on the root node. The value for the low high, like I mentioned, that the lowest the value could be negative infinity, right? And then the highest the value could be infinity. So I'm just gonna say that float and negative infinity. This is how you do it in Python, and the high value could be infinity. It could, so in this case, it's actually, I want to make sure that it's not a no value so that I can make sure that it won't have, basically the error is saying that it could be, the vol could be none type. So because I added a condition check, so it could be if not node, not just the root node, but it's the node here. And I just modify this, and this time it should be right. If you think this is helpful, please like my video and give me a thumbs up, and I'll see you soon with more Leetcode questions. Bye bye.